Hello, this is Karsten Busby and Keelan Jensen of Car Key Computing, presenting Give Me One Reason to Stay Here. To begin, our problem is the following. We want the 10 best cities for families, and we got a list of that from the Parenting Magazine online. The following is our list from Boston to Sioux Falls. So we took that list of cities, and within those cities, we found the best places for families to live based on a couple criteria. The data that we have to work with are shown here. This is just one example city, Cheyenne, Wyoming. So this is the city limits of Cheyenne, and within this folder we have shapefiles for airports, for the freeways, the city limits, the schools, and the Walmarts. So our criteria were you want to be a good distance away from airports because they're noisy, obviously. You want to be within the city limits. You want to be close to freeways but not too close. You want to be pretty close to schools, and then with Walmarts, similar, you want to be close but not too close. So as an example, this is Cheyenne. There's one Walmart within the city limits. There's a couple of airports. There's all the schools that are within the city limits, and then we got freeways for each of our cities. So to start, we created a model builder model, and I'll show you a couple of the steps within the model. We took our shapefiles that I just showed you, and we created a buffer for the city limits so that our map would include things that are just slightly outside of the city limits. For example, there was an airport that was close to the city but not within it. And then we clipped each of our shapefiles to that buffer. After that, we created these custom buffers for each of our shapefiles. Some of them were multi-ring buffers and some of them were just simple buffers. And then we converted those buffers into rasters. The reason we did that is so that we could reclassify them and then add those together using the raster calculator. So what that gave us were values from 0 to 4, with 0 being the worst places in that city based on these criteria and 4 being the best. So that created a scale that we could use to display in our final atlas. After that, we exported our model as a Python script. And Keelan is going to go over that script in just a second.
Thanks, Karsten. So as Karsten said, this is our exported script. You see here at the top we kind of have the copyright information Dr. Ames told us about today. And here's the description from the model builder. So this again is a script that will find the best places to live in the 10 best cities in the United States and print those locations into a PDF atlas. So to start in our script, we have to import all the modules we use. And in this case, we used ArcGIS OS and the time module. We didn't use the shell utility module, and so we didn't import it. That was just kind of keep our code simple. Then we kind of set some of the global variables and settings to start out here. So first, we want to make sure that when we are able to overwrite a file, because a lot of our intermediate files are saved in the same geodatabase as the same name. That kind of saves space and prevents ArcGIS from getting too cluttered as it's running this program. Here then we define what we call our home path, which is the main folder that all of our other folders and files are located in, and where all of the resulting outputs will be saved. And this is the only parameter in our script. The user gets to specify what this main folder is, and so that's the get parameter here. After that, we are going to create our PDF document, our PDF atlas, using our home path, call it an atlas. And then we're going to define our main folder and get a list of, we define our main folder here, which is in our home path folder, and get a list of folders in that main folder. And this list of folders is, as Karsten showed you, the individual city folders that we created for each of our top 10 cities. Just checking out extensions here. And then we enter our first for loop. The structure of our code is 2 for loops, and the reason we have 2 for loops is because when we tried to run everything in one for loop, it tended to crash ArcGIS, and so to kind of slow down the processing or reduce processing requirements for GIS, we divided it into 2 loops. The first loop here is a geoprocessing loop, which takes care of all of the data manipulation and creates the actual output data, and the second loop, which we'll show you in a minute, we'll go take that data and create a PDF from it and then put it in the atlas. So first, what we did is we added throughout here some messages to let the user know where the program is to show them the progress, and in case there's a crash or a bug and something goes wrong, it lets the user see, kind of gives them an idea of where that bug occurred. So here it's going to say we're starting, and then it tells you the city. Here we define just the global variables, mostly rasters and clips and buffers. And we set our workspace, and we define the important variables that we have to input here. Walmart, schools, airports, city limits, final maps, that kind of stuff. Another thing we did in our code to help prevent GIS from crashing is we added this sleep command, so it waits 5 seconds in every loop to make sure that GIS doesn't start going too fast for itself and kill itself, which it tends to do. So as Karsten said, this code is mostly exported from our model. Here we're buffering the city limits, clipping the freeways, some stuff like that, reclassifying freeways. This is all pretty simple. One of the things we had to do in here is change the extents of our rasters. And the reason we had to do that is when our rasters, only parts of them would overlap, or if none of the rasters would overlap, when we tried to add them together, it wouldn't give the desired output. So the first thing we did here, when we're changing extents, is we set our initial extents to a variable so we can maintain those. And then we set the extents of our processing to just the reclassified freeways raster. The reason we chose that is because we found that for the cities, because the freeways go through the city rather than just being at a point in the city, the freeways tended to cover, the raster tended to cover the entire area of interest. And so we set all of our rasters extents to the freeway reclassified raster. And so then here we're reclassifying airports, and again we're going through all of the schools, airports, Walmarts, and we're clipping, buffering, converting the raster, and reclassifying that. And then here at the end, we set the extents back to their original values so that we didn't mess up any later calculations or geoprocessing in GIS. And then we had to add the rasters together. Now, map algebra, as you've probably found, does not necessarily work very well in Python, at least for ArcGIS 10.0. And so what we had to do is we had to use the spatial analyst stuff in ArcPy, and we set a new final values raster, as we defined earlier, to be the sum of our other rasters. And that way our final values raster would have values from 0 to 4 depending on the quality, or the quality of location. And then we extracted from that we extracted just the locations within the city limits from that final values raster, and we let the user know here that we've created the raster for that city and we're going to move on to the next city. And so that's our geoprocessing loop. Like I said, that just goes through basically what that model does, creates all the rasters for each of the cities. And then we're entering here the loop that will create the PDF files from the actual output data that we created with our previous loop. So first we're kind of setting the variables again just to make sure that we didn't mess something up as we were going through that previous loop. The workspace, the global variables, the layer name, and again we're adding a message to let the user know, hey, we're done with the geoprocessing, we're going to start the maps now. Defining some more variables here, our map and our data frames. And we're getting into this code that Dr. Ames showed us here that creates a layer so that we could set that layer's attributes and then export those attributes to our layer of interest. And so we're creating the layer, we're pulling out what we need and adding that layer to the map here, and then we're importing the symbology to our raster. We're defining our symbology raster, we're importing the symbology to our raster of interest, and we're changing the transparency here so that you can see through the output and look at it on a base map. And then we're refreshing the view. And so then what we're going to do here with this code is we're zooming into just the city limits, because we're not really interested in much beyond that. So here we define a variable described to be the city limits. We set the extents of our data frame to the extents of the city limits. We're starting to change a little bit in our layout here. So we have our title, and we set it to the name of our title, and then we're changing it so that for each city, the map is going to be titled the name of the folder, which, as we have it set up, is the name of the city and the state it's in. And so each map will have as its title the city and state. And then this shows our attempt to make the legend uniform. As you all know, there were some problems with the legend, and so this fixed some of it, but not all of it. And we're saving the PDF, exporting it, adding it to our atlas, removing the PDF to remove clutter, and letting the user know here that our map is done and we're moving on to the next city. And so it goes through this loop for each of the folders in that main directory, each of the towns. And then when it's done with that, it saves our overall atlas and closes it. And so that's our code. It's not too complicated, but now I'm going to hand the mic back over to Karsten. He's going to show you how to run the code in ArcGIS.
Okay, so when we give the script to a user, they'll receive this folder just called Best Places. And within that, you have your individual places, and the user can actually change these. They can pick their own cities if they want, name them whatever they want, as long as they have those required shape files that we showed you earlier. And so all they have to do is open this bestplaces.mxd file to start running the program. And I'll do that from within ArcGIS since I have it open. So once you open this up, this is your basic layout. And then it's already set up so that there's a toolbox in your home folder, and there's a script inside called Best Places. So you just have to double click on that script and it'll start the program. You need to specify where your main folder is. Python doesn't do relative references, so before you start, you need to specify where that folder is that I showed you that we give to the user called Best Places. You have to specify where that is. And then you run the program. We're going to pause the video while this runs because it can take a little while, so we'll be back in a second. Okay, so the model finished running, and as you can see, it kind of printed out things as it was going. It says the map's done, you know, and early on it says that it's working on the raster. So it's informative output. And then we'll show you really quick what was actually output. Within each of these places, there's now a final map, and that's the raster that was created for each one. So, for example, Sioux Falls. That's how it looks before it's formatted. After it's formatted and published to an atlas, it's within that same folder, the Best Places folder, called atlas.pdf. And here's the output. So it has the title that's used, the city name is used for the title, and then it has the legend at the bottom with the different qualities, and on the map it shows where the best places are. So if you look at Austin, Texas, for example, the darkest areas are the best, and the lighter red is good places to live. We didn't include the places that weren't good to live because they don't interest us, and so it does that for each of those 10 cities in one PDF. You might notice that there are some issues with the legend. The sizing changes a little bit, but we couldn't fix that. It's kind of a bug in ArcGIS 10.0, and so that's just something we have to live with. But the legend does look good on the first couple, so you can figure out what the symbols mean. So that's basically our program, how it works and how to use it. We hope you enjoyed our video, and we will see you next time.